Guys, some exciting news. We figured out some technology here, and now when I do a video, you'll be looking right at my notes instead of at the screen behind us. So super, super exciting. These videos should be much more viewable for that purpose. So here we go, lesson 19, and this is all new, so make sure we're watching these videos. They're not that long. 19.A is on non-linear systems. So nonlinear systems means that you're going to have possibly one thing that is linear or maybe nothing that is linear. So you are going to be involving some conic sections, and that is review. So nonlinear systems, at least one equation is not a line. And so I'm going to go over the structure of our conic sections in case we've forgotten. So let's first start. You should be able to recognize a line, y equals mx plus b. What makes what makes it linear is that it has a degree of 1. Now, so let's review some conic sections so you remember what those look like. So here are our nonlinears that you could see. A circle, standard form of a circle is x squared plus y squared equals r squared. And just review, r is your radius. Okay. So notice the degree on both x and y is squared. You also have an ellipse. So remember here, a line, a perfect circle. An ellipse is an oval, and it looks like the following: x squared over a squared plus y squared divided by b squared equals 1. Remember, it is the shape of an oval. And last is a hyperbole. Oh, silly Michelle. A hyperbola. And it looks like an ellipse that's cut in half and flipped so that it faces outward. So line, circle, ellipse, hyperbola. And the only difference between the formula between an ellipse and a hyperbola is that you have a subtraction sign in the center instead of a plus sign. So when we are solving systems today, we're finding the points of intersection. Okay? For example, if I had a line and a circle, then I'm looking for the place that those two functions intersect. So the coordinates at which they intersect would be my answers. Okay, so we're going to do a couple together. We are not having to graph, so if that alleviates your fears, we're not graphing, we're finding the points of intersection. Okay, so we're looking for where they intersect. So let's example number 1. We're going to solve x squared plus y squared equals 9 and y minus x equals 1. Now, I like to know exactly what I'm looking at. So if I was to look at these two, this doesn't equal 1 and there's no denominator. So I know this first one is a circle and I know this one is a line. So I'm looking at the place that this line intersects the circle, and I could have 1 or 2 points of intersection when it comes to that. And I'm just going to put 1 or more because in a hyperbola you could have more than 2. So 1 or more, but it is possible to only have 1, and that would be the case that a line is tangent to a circle. So the easiest way to solve is to use substitution. In this case, it's because my degrees are different. I can't use elimination, but so I'm going to use substitution when the degrees are different. So I am going to get y by itself. So y equals, I'm going to add x to both sides. And I'm going to substitute that into the function of the circle. So I'm substituting what y equals into here. So that would give me x squared plus y squared equals 9. But we're substituting x plus 1. Okay, so there's what it's going to look like. So now I'm going to multiply. So that would give me x squared plus x plus 1 times x plus 1. Hopefully, through this class, you're going to get really good at multiplying binomials, identical binomials. So that gives me x squared plus 1x plus 1x plus 1 equals 9. And we can either solve using the quadratic formula or using factoring, but more than likely we're going to be quadratic formula. So get all on one side, solve using quadratic formula. So x squared, there's 2x squared, right? If I combine like terms, plus 2x minus 8 equals 0. I subtracted the 9. You guys can follow that. And then I'm going to use the quadratic formula. So remember, quadratic is negative b plus or minus b squared minus 4ac all over 2 times a. So in this case, I would have negative 2 plus or minus 4 minus 4 times 2 times negative 8 all over 4. I would enter this in your calculator. We enter this first. Okay, so I get negative 2 plus or minus, that would be 4 plus 64, if I am correct, because 4 times 2 is 8, 8 times 8 is 64. So that would give me the square root of 68 all over 4. And then I have to simplify the radical. And you have to do that first before anything else. So x equals negative 2 plus or minus 68 is, I believe, 4 times 17. So that becomes 2 root 17 all over 4, which equals negative 1 plus or minus the root of 17 over, and each of these is over 2. That is how I'm going to write it. If you guys don't want to write it that way, then you can put all of this over 2, right? Because I reduced each of these by 2. Sorry, you can't see that. So this is what I get for x. Now, I believe you can place this in decimal form, but I want you to leave it. So I'm going to write it as negative 1 over 2 plus or minus root 17 over 2. Now that only tells me x. I have to find where these where they intersect. So I need to find y. So let's say I'm going to plug it into that bottom equation. So I'm going to y equals x plus 1. Okay, so I'm plugging in the first x value, negative 1/2 plus the root of 17 over 2 plus 1. And then I'm going to plug y equals the other x, negative 1/2 minus the root of 17 over 2 plus 1. Now, the only two things I can combine are my fractions, right? Not my fractions, my real numbers. Okay, so my integers. So 1 minus 1/2 gives me a y value of positive 1/2 plus 17 over 2. So the first point of intersection, remember this is x and this is y. So my x value was negative 1/2 plus 17 over 2. And my y value is positive 1/2 plus root 17 over 2. So that's one point of intersection. So I plug this in for x. Remember, there are two different answers here. Okay, this represents x. So I'll label that. These are my x values. And one of them is negative 1/2 plus, one of them is negative 1/2 minus. Next one, again, this is what I plugged in for x. This is what I got for y. So now this is what I'm plugging in for x. And the only two things I can combine is 1 minus 1/2. Again, is positive 1/2 minus root 17 over 2. And so this is what I got for y. So my next point of intersection, I plugged in negative 1/2 minus root 17 over 2. And for y, I got positive 1/2 minus root 17 over 2. And so these represent the 2 points of intersection between the line and the circle. Crazy. Oh no. We're going to do another one because I'm sure that seemed a little bit crazy. So the next one we're going to solve. X squared plus y squared equals 9. 2x squared minus y squared equals negative 6. Now, it doesn't really matter if you recognize what these are, but I know the first one is a circle, and I know the bottom one is a hyperbola because of the subtraction sign. Now, to solve these, substitution would be ridiculous. So solve by elimination because they have the same degree. So notice these are both x squared, x squared. So I can simply add them because y squared will eliminate. That's why it's called elimination, because if I add these equations, it'll eliminate y squared. So that gives me 3x squared equals 3. Divide by 3, x squared equals 1, square root, x equals plus or minus 1. So this function is actually a lot easier. Notice we already have both solutions for x. Now I have to plug them both in for y. Now remember, I could have more than one place that these intersect, okay? So I'm going to plug in both positive 1 and negative 1. Okay, so I'm going to plug x in to find y values. So I'm going to use the top function. So x squared plus y squared equals 9, but I'm plugging in a 1. And I get y squared equals 8, right? Because I have, for 1, I'm just going to subtract. And then I'm going to take the square root. So y equals plus or minus 2 root 2. So when I plugged in positive 1, I found two different answers for y. So if I had a pencil, when I plugged in a positive 1 for x, I ended up with two different, right there is two solutions for y. One of them was positive 2 root 2, one was negative 2 root 2. So now I'm going to plug in negative 1. So negative 1 squared plus y squared equals 9. That leaves me with 1 plus y squared equals 9. So y squared equals 8 square root and y again equals plus or minus 2 root 2. If you're wondering where I get that, it's the square root of 8 is 4 times 2, which gives me 2 root 2. So notice when I plugged in -1, I got two solutions for y. One of them was positive 2 root 2, one was negative 2 root 2. And so these 4 points of intersection are my answer. Okay? So notice in this case I have 4 places of intersection. All right, we're going to do one more so that you are confident in solving these. So number 3, solve x times y equals -4 and y equals -x minus 2. Now I'm giving you lots of possibilities because I want you to be confident. So for this one, let's talk about whether I would do elimination or substitution. I can't do elimination because these are being multiplied. So the easiest way here would be to solve by substitution. Okay, because I already have y by itself. So I'm going to say the thing, I'm having to write these down versus if you were in class, I would just say them to you. So I'm going to simply substitute the value of y into here. So x times y equals -4, but we're plugging in -x minus 2, right? We're substituting what y was into the top function. Sorry, took a drink of my smoothie. Now I'm going to distribute, so -x squared plus 2x. And I'm going to move the 4 so that I can solve using quadratic formula. So x equals -b plus or minus b squared minus 4 times a times c all over 2 times a. That gives me -2 plus or minus the square root. This would be 4 plus 16, right? -4 times -1 is 4. 4 times 4 is positive 16. So that would give me the square root of 20 all over -2. Sorry, I'm going to erase that. So x equals -2 plus or minus 2 root 5 over -2. Remember, you have to simplify the square root of 20 first. You cannot make -2 over -2 a 1 yet. Okay, so this would equal 1 plus or minus the root of 5. Okay, so I have two solutions for x. I have x equals 1 plus root 5, and I have x equals 1 minus root 5. So now we're going to plug x in to find y. So I'm going to use this equation up here, y equals a -x minus 2, right? And I'm going to substitute x right into here. So, I'm going to plug in the 1 plus root 5, and that gives me -1 minus root 5 minus 2, which equals -3 minus root 5. Right? I feel like I did that wrong in the prior year. Did I mess up? No, I think that's right. So my first point of intersection is 1 plus root 5, comma, -3 minus root 5. Then I'm going to plug in the other one, -1, 1 minus root 5 minus 2. That would give me -1 plus root 5 minus 2, which would give me -3 plus root 5. So when I plugged in 1 minus the square root of 5, I got -3 plus root 5. And so those are my 2 points of intersection. All right. Moving on. Sorry, my screen locked. Hold on. I realize I did more examples than normal, but that's because I want you to be able to do this section. So 19 point B is also brand new, and it's factoring exponential functions. And so we do need to do some review. Remember that when I multiply, you add exponents. You're also going to have to know difference of 2 squares. All of this is review, so a squared minus b squared would equal a plus b and a minus b, where you would cut the exponent in half, so half of 2 is 1 and 1. And you're also going to need to know the sum or difference of 2 cubes. And this one's a little bit harder, so a cubed plus b cubed equals a plus b, a squared minus a times b plus b squared. Difference of 2 cubes, again, this is all review from Algebra 2, would be a minus b, a squared plus a times b plus b squared. Remember the SOAP acronym to remember your signs. Same, opposite, always positive. Same, opposite, always positive. So here we go. In 19 point B, let's factor. We're going to factor 3x to the 2n plus 2 plus 12x to the 3n plus 3. Now, I know that this is going to be kind of crazy looking, so bear with me. So the first thing I notice is that 3 and 12 are both divisible by 3. Okay? Now, the next thing I notice, if I just look at 2n plus 2 and 3n plus 3, I notice that these have, like if I factor each of these separate, this is 2 parentheses n plus 1, and this is 3 parentheses n plus 1. So what do they have in common here? I know that they have the n plus 1 in common, but I also noticed I could look at it as I could take out a total of 2n plus 2. And let me explain. When we multiply, we add our exponents, okay? So you could also look at it as 3x to the n times x to the n times x squared. That is how I would get 3x to the 2n plus 2, because I don't multiply these, I add them, and n plus n is 2n. So when you think of it that way, this one is simply 3x times n times n times n times x cubed. So notice that each of these has 2 n's. And I could take out at least x squared. So I could take out at least plus 2. And what would be left inside, or, I mean, you can think of it, you can do this in multiple ways, but this would be x, there would be nothing here but 1, because these are the same, plus 3 to the x to the n plus 1. Because when I multiply these, 2n plus n is 3n, and 2 plus 1 is 3. So I know that's hard to see. I could break this down even further. So I could take out at least 3x 2n plus 2 because I can take out at least x squared. So that would be your that would be your greatest common factor. So that's why I took it out. I know it's hard to see, so we'll practice a couple. Let's try factor, and sorry, this covers so let's factor, sorry, I'm jumping around here. Let's factor x to the 2a minus y to the 2b divided by x to the a plus x to the b. All right, so I'm going to factor this. On the top, I notice that this is a difference of 2 squares, okay, because I know that x to the a times x to the a equals x to the 2a, because you're adding. I know it looks so different, but 1a plus 2a is 1a plus 1a is 2a. You're adding those. So this is actually up here, this is a difference of 2 squares. So I would have xa plus yb and xa minus yb divided by xa plus yb. These would cancel, and I'd be left with xa minus yb. I know that's crazy. Okay, next one. Factor 4x to the 4n plus 3 minus 16x to the 2n plus 1. Okay, so let's try another one of these. Hopefully you can see I'm going to have a 4 and I'm going to have an x. What could I take out of here? I could take 2n out of each one. And here, well, the minimum I could take out is 1. Okay? So left inside for this one would be x squared, because when I multiply these, I can only combine like terms. 2n plus, the like terms would be 3, minus 4x. I already have the 2n and I already have the 1, so this is actually just x squared minus 4. Okay? Now, this, whoops, I messed up, huh? This would be 2n plus 2 minus 4. And I'm going to leave it like that. Next one, I'm just going to put, you can put factor or simplify. X to the 6b minus y to the 6b over xb minus yb. Now, I feel like I wrote this wrong. This should say, hold on. Sorry, this should say 3b. Okay, so hopefully you recognize x to the 3b times x to the 3b would equal x to the 6b, because you're adding like terms. So when I factor this, the top could be cut in half, 3b, 3b, and y, 3b, y, 3b. One would be plus, minus. And then hopefully you can already see what is going to cancel, and that is these. So x to the 3b plus y to the 3b is your answer. Okay. Last two, I know this section is long. 19.C is more factoring exponentials, but this has to do with your difference and sum of two cubes. So the difference or sum of two cubes. Now I already wrote the patterns on the last page. So here are the last two problems. So we're going to factor x cubed y cubed minus p cubed. Remember you have a cubed plus b cubed, which equals a plus b, a squared minus ab plus b squared. And your difference of two cubes looks identical, but the signs change. A minus b, a squared plus a times b plus b squared. So I'm going to identify the terms cubed. This is p cubed, and this here is xy cubed. So I know that this inside here, that technically is a, and this is b. So my factors are xy minus p, according to this pattern, x squared, y squared, I'm merely squaring them, plus, multiplied them all together, I put them in alphabetical order, plus p squared. And that is your answer. Next one, factor 8m cubed y to the 6th plus 27x cubed. So I'm going to identify what these terms are squared. 27 is 3 cubed and x cubed is x. So there's my b. That's b. Plus 2 cubed is 8. M, this would be y squared. Remember, an exponent raised to a power, you multiply. So you're technically dividing. 3 divided by 3 is 1. 6 divided by 3 is 2. So there is a. So my factors are simply 2m y squared plus 3x, a plus b. Now a squared would be 2 squared, second term squared, next term squared, minus a times b would be 6my squared x. I should have put those in alphabetical order. Plus 9x squared. And those are my factors. I know that's a long section. So homework 19, you're going to skip numbers 4, 6, 15. Did I skip 19? Hold on. No. And 23 through 25. So I do take 6 problems off, and we are